2.2 direct variation, also 8.1 inverse and joint, and then combination variation. And this will include word problems. So this section is very important to mostly solving word problems. We're going to talk about the setup and what the graphs look like, but you'll be applying what we do to word problems that we'll do in class. All right, so let's get started. All right. All right, direct variation, you've talked about before in Algebra 1. It's where y varies directly as x if exists a constant k that's not a 0. All right, so the equation for a direct variation is y equals kx, or sometimes if you solve it a different way, if you wanted to just solve it for k, that's going to be k is equal to y over x, okay? Either way, it's the same thing. Mostly you'll be using the y equals kx form. You do need to memorize this, as none of the variation forms are in your formula sheet. So you need to memorize all these. The main thing with direct variation is just remember it's multiplication. So it'll be set up like this, not that difficult to remember. But when you're working with a graph, we'll talk about where that would apply more for this type of formula. All right, so the graph of a direct variation always goes to the origin of the graph. So if I drew a sketch of a direct variation, it would go straight through the origin like that, or it could also go in this direction through the origin in a negative fashion. Okay, either one of those is a direct variation because there is a constant that stays the same on each line. All right. When interpreting word problems, you're going to want to think, let me switch my color back again, more equals more or less equals less. These are things that help you figure out which one it is. If you have something and you have more equals more, it could be a direct variation or a joint variation. And less equals less, same way, okay, because it is the same change. As one quantity goes up, the other one does too. Or if one quantity goes down, so does the other one. Okay, so think more equals more or less equals less. It's a really easy way of thinking about these and interpreting word problems. So for example, interest on a loan. Okay, the longer it takes you to pay that loan, the longer, that means more, the more interest you're going to be paying. So that would be a more equals more. The accidents reported, fewer cars on the highway, less. Fewer accidents are likely to occur. So fewer cars means fewer accidents. Less equals less. Now, if you're given a table, you're going to divide all the y values by the corresponding x value. If all result in the same number, then it's a direct variation. That's where you're going to look at this y divided by x thing. So if I take each one of these ordered pairs and I would say 10 divided by 5, does that equal 16 divided by 8? Does that equal 40 divided by 20? Okay, 10 divided by 5 is 2. Does that equal 16 divided by 8? That's 2. 40 divided by 20, is that 2? Yes. So this is a direct variation, and my constant of this table, k, would be 2. Okay, that's the constant of variation, which is the change in rate. Now, if you can write an equation in that y equals kx form, then it's a direct variation. For example, if you had 4y equals 2x, well, if you solve that for y, you would have 2 over 4x, which is the same thing as y equals 1/2 x. That is in direct variation form. Whoops, there should be equals in there. Y equals 1/2 x, and that is a direct variation. There is no b on the end, And if there's no b, then it is a direct variation. Now, on the next equation, it says y plus 2 equals x minus 2. Well, we want to solve for y. So I'm going to subtract 2. So y would be x minus 4. Right, that minus 4 right there makes it not a direct variation. Okay, because you cannot have a b, because if you had a b, then, it would not go through the origin. So if you can put it in y equals kx, it would be a direct variation. All right. Now, when finding values using direct variation, you're going to solve for the constant k first. This is the rate of change. So, for instance, y varies directly as x, and y is 12 when x is 18. You're going to go left to right and do it in pieces. Always start with your formula, y is equal to kx, and then plug in what you have and solve for k. So it says y is equal to kx, and it says y is 12, so I'll put in a 12 there, equals k, and then x is 18. So when you solve for k, you're going to have 12 divided by 18, which simplifies to 2/3. 6 goes into both of those. So your constant of variation is 2/3. That's your k. Now, most of the time you won't be just asked what the constant of variation is. Mostly you'll have to solve things. So then you'll take it one step further after you find k. So, for example, in the next one, it says y varies directly as x, and y is 12 when x is 30. Find y when x is 5. So this is in 3 parts. You would determine your formula. Y varies directly, that's this part. That's number 1. Okay, then plug in 12 and 30 into the second part. That's part 2. Okay, this is part 2 right here. 12 equals k, 30. Solve for k. You'll get k is 2/5 when you simplify it. Then you're going to take that k and plug it into your equation and finish finding it. It says find y when x is 5. So if we know what k is, we plug that in. It says when x is 5, we find y. So 2/5 times 5, which will give us y is equal to 2. So you're going to do this in 3 parts. Okay, you're going to establish your formula you're going to use. You're going to solve for k. And then you're going to take k and plug it into your original equation with your new information and solve the answer. This is the part that you'll be solving for at the very back. Okay? Alright, so inverse variation is a variation exists when one quantity increases but the other one decreases. Okay, so it's like, the more things cost, the less people buy, kind of thing. All right, the equation is y is equal to k over x, or k divided by x. Inverse variations work with division. Okay? All right, so the equation, like I said, is y is equal to k divided by x, or if you solved it for k would be equal to y times x. In this example, you're going to think more equals less, okay? More equals less. Because one quantity has to be increasing, the other one decreases. So, for example, the more money you spend each month, the less you will have to save. The more money, the less you have, okay? So that's going to be inverses. So let's go work on some of these. Now, let me talk about the graph of the inverse function, okay? This is the graph of y is equal to 1 over x. That's what this one is right here. The inverse variation. And as you notice, as x approaches positive infinity, y is getting closer and closer and closer to 0. It will never cross the x-axis. Same over here. This one's coming up from this direction. Like I could draw the arrows right there and there. Okay? So as x is approaching negative infinity, y is getting closer and closer and closer to 0, but it will never be 0 and it will never cross. Okay, this is an inverse variation graph. This is a parent graph, and you can shift these things around just like any other parent graph. But this is the inverse variation, so it's not going to go through the origin ever. It's never going to touch 0 on your y. Okay? Because as one goes up, the other quantity goes down. All right, so example of inverse would be like if y varies inversely as x, y is 12. When x is -3, find y when x is -18. Again, you will determine in 3 parts. 1, the formula you're going to use. 2, the second information to find k. And 3, plug in to find your final answer. So my formula for inverse is y is equal to k divided by x. And then the second part, plug in your stuff that you have. 12 is y and -3 is x. So I have 12 is equal to k divided by -3. When you solve for k, k will be -36. Now I take that k, put it into my original formula again, and solve. It says find y. Sometimes it says find x, so you just have to set it up whichever way they want. Y is equal to, k is -36 divided by -18. And when you do your math, y will be 2. Now, if you're given in a table and you want to know if it's an inverse variation, or you want to determine if it's an inverse variation versus a direct variation, you were dividing these y divided by x in order to get a constant variation. But with inverse, you're actually going to multiply your y times your x. Okay? If that becomes the same number, then it's true. So let's look at these. Let's do, start with this one. 85 times 3. What does that equal to? I believe it's 255. Yeah. 255. All right. And then 51 times 5. That equals 255. And then 15 times 17, does that equal 255? Yes. So 255 is the same all the way through it. That means it is an inverse variation, and that means that 255 would be my constant k in this particular problem. K would be 255. So when you're looking at an inverse, you're multiplying them. When you're looking at a direct, you're dividing your y by your x. So when you're multiplying these, try to do it the same way, y times x. That way you'll get into the habit of going that direction. You won't mess up your direct variations. All right, so joint variation, now that's a different one. Joint variation is where you're going to have a combination of 3 different things, okay? Y varies jointly as x and z. So there's 3 different things being put together. Jointly is going to be multiplying also. Okay? The equation for joint variation is y is equal to k. And you notice k we always have first, xz. K times x times z. Okay? And that is all multiplication. Or you could set it up like this, where you have y1 divided by x1 and z1. Does that equal y2 divided by x2, z2? Sometimes it's easier to use this form than this. It just depends on what they give you. And most of these can be set up by proportions if you wanted to. Now with joint variation, a good example, because there are 3 variables, would be volume. Volume depends on the length times width times height. You know, it's 3-dimensional. So that would be, you know, we're talking about a cube. See if I can draw you a cube here. Ooh, not super bad. Length, width, and height. Okay, so you're going to think also with this one, similar to direct, more equals more. Okay, but the way you'll be able to tell the joint versus the direct variation, the joint variation will have 3 elements versus the direct variation, which will only have 2. Alright, so suppose y varies jointly as x and z. Find y when x is equal to 8 and z is equal to 3. If y is equal to 16 when z is equal to 2 and x is equal to 5. So there's a whole lot of numbers in there. This one would be easier to use this formula because it's set up for you with all these numbers. So we're looking for y. So y, this would be step 1. Well, after you figure out which formula, let's call that 2. Let's call this 2. Figuring out your formula is always step 1. Alright, so we're going to plug in what we've got. Y, we're looking for. X is 8 and z is 3. That goes beneath it. It says y is 16, this is part 3, when z is 2 and x is 5. So you would plug those in, and then you would set them up and find y to be divided by 24. Does that equal 16 divided by 10? Well, then you have a proportion where you cross multiply. So you're going to have 10y is equal to, let's see what 16 times 24. Whoops. Hold on, I'll tell you what it is. 384. So 10 divided, I should have known what that was. 384. Okay? And then divide by 10, you get y to be 38.4. Alright? So just set them up, determine which one you want to use, and then go from there. You do, again, need to know these formulas as you will not be given these on any formula sheet. Alright, now, combination variation. Sometimes you're going to have to make a combination variation formula to solve a problem. So you'll be given different information, and the wording will tell you exactly how to set it up. Remember, direct variation, you multiply as you do with joint, and inverse is going to be dividing. Okay? So if that's the case, it says y varies directly as x. Remember, you have to have the k in there. So y varies directly as x is the y equals kx thing. And then it says inversely with z. That means dividing by z. Okay? So set up your formula reading directly left to right. Alright, so this is where you get this formula for this particular setup. They will have different setups. You're going to have to read across and set it up depending on what they say. They could even say inversely with z squared, and you'd have to put a little 2 there. You just have to read left to right and set it up. Direct variations are multiplying, inverses are dividing, joint variations are multiplying. And then you're going to solve it just as you did before. You'll also be solving word problems with variations. The key to these is to read these and write these from left to right and define your variables. It is extremely important that you read left to right. You may not use a y or x. You may want to use some other letters. As long as you solve it and set it up left to right just like you would, you can even write your variation formulas and then change your letters if that's what you need to do. For example, the cost of bananas. Now I'm talking about the cost. I'm going to put a C right there. Varies directly, okay, with the weight. I'm going to say W. Alright, so it's a direct variation. I know that looks like this. Okay, but I'm going to go left to right, and instead of Y, I'm going to put a C. I'm still going to use K for my constant and then W for my weight. Okay, so that way it makes a little bit more sense. Alright, so now it says if 4 pounds of bananas, 4 pounds is the weight, so 4K, and 4 pounds of bananas cost me $8. Alright, so I need to solve for K, so dividing by 4, K is going to be 2. Then it says, how much would 9 pounds cost? All right, so I don't know what the cost is going to be, but I do know K, and I do know now I have 9 pounds. So the cost would be $18. A lot of bananas. And I'm not even sure the cost of bananas, but that, I just wanted to set that up so you can see what it would look like. So, cost of bananas varies directly. Now, sometimes on the word problems, they're not going to say varies directly. They're going to say the cost of bananas is proportional to the weight, or something like that. You know that the cost of bananas is determined by the weight of them. So you'll have to look and see if it's more equals more, less equals less, more equals less kind of situation, and then you know which one to set it up. A lot of times the word problems they'll give you will say directly varied or whatever, but not all the time. And that's when you're going to have to think about what's happening in the problem. Okay? All right, so we'll work with these. I'm pretty sure that was the end of my slide. Yep. We'll work with these in the class, and we will do lots of word problems in setting these up. You need to memorize all of the formulas, the little bitty formulas, so that you will know what's going on and have an idea of what to use. Otherwise, you're going to be in a lot of trouble trying to do these word problems without knowing these. It's not a lot to memorize, so I think you can handle it. All right, come see me in school, and I'll talk to you in class.